Earlier in this course, we learned a little bit about arrays. In this lecture, we're going to take a deeper look at arrays. So first, I'm going to have a quick review of arrays. Then I'm going to talk about different types of arrays we have in C#. And finally, I'm going to introduce some useful methods to work with arrays. So just to refresh your mind, an array represents a fixed number of variables of a particular type. In C#, we have two types of arrays: single-dimension arrays and multi-dimension arrays, like a matrix. So single-dimension arrays is what you have seen before. In this example, we have an array of integers called numbers, and the length of this array is 5. If we know ahead of time the values we would like to store in an array, we can use the object initialization syntax to initialize that array upon declaration. So nothing new so far. Now let's take a look at the types of multi-dimension arrays. We have two types of multi-dimension arrays in C#, rectangular and jagged arrays. So with a rectangular array, each row has the exact same number of columns. So in the example you see in this slide, we have an array of 3 rows and each row has 5 columns. With a jagged array, however, the number of columns in each row can be different. A different way to look at jagged array is an array of arrays. So you can think of the jagged array we have in this slide as a single-dimension array with 3 elements, and each element is another single-dimension array. Now, what's the difference? When do we use a rectangular array or a jagged array? In .NET, CLR is optimized around single-dimension arrays. So let's say you want to model a matrix. It's faster to implement it using a jagged array than a rectangular array. Having said that, the difference might be really tiny, especially with the computers we have these days. So my pragmatic advice to you is don't get stuck about the difference between rectangular and jagged array too much. Just be aware that in C# we have two types of multi-dimension arrays. Now let's see how we can declare a rectangular array. So here is the syntax for declaring a two-dimensional rectangular array. So the only new thing you see here is that in the square brackets, we need to specify the dimensions of the array. So in this case, this array has 3 rows and each row has 5 columns. If we know the values we would like to store in this array ahead of time, we can initialize this array using object initialization syntax. And if you want to access an element in this array, just like before, we use the square brackets, but we need to supply the index of the row and the column. If we want to declare a 3-dimensional array, we can extend the previous example and supply 3 dimensions while declaring the array. So in this example, our colors array has 3 dimensions. Now let's take a look at the jagged array. So imagine we want to model an array that looks like this. So as I explained earlier, you can think of this array as array of arrays. So at the top level, we have a single-dimension array of 3 elements. In each element, we have another single-dimension array. So in our first element, we have an array of 4 elements. In the second element, we have an array of 5 elements. So how do we implement this? Well, first we need to declare a top-level array. Note the syntax here. We use 2 square brackets to represent a jagged array. In the first square brackets, you specify the number of elements in your top-level array. Now we need to initialize each element of this array to a different array. So we are specifying that the first element of this array is another integer array of size 4. And to access an element in this array, again, we need 2 square brackets. So the difference between the jagged array and rectangular array from a syntactical point of view is that with jagged array, we have 2 square brackets, whereas with rectangular array, we have 1 square bracket, but we separate the dimensions using a comma. In C#, all arrays map to the array type that is defined in the system namespace of .NET Framework. So the array type is a class. It has a bunch of properties and methods as you see in this slide. Okay, now let's flip over to Visual Studio and see all these concepts in action.